Welcome, geometry students, to section 6.7, polygons in the coordinate plane. This is a tougher section, but a very useful one. It really gets to the core of a lot of these tough problems on the coordinate plane. You have to have some background knowledge on different shapes, but this one really kind of breaks down and is a good review for a lot of processes. Let's go ahead and get started. So the formulas you'll need to use with these shapes with polygons. The first we have is the distance formula. Let's remember what the distance formula is. So the distance formula is d, distance, equals the square root, that was a nice straight line, x2 minus x1, those are your two x coordinates, squared, the difference of them, squared, and then we have y2 minus y1 squared. Let me extend that line a little bit. Okay, so there we go. The difference between the x coordinates squared plus the difference in the y coordinates squared. Also think Pythagorean theorem. That also works. Pythagorean theorem. That's my preferred method, actually, which the distance formula is derived from the Pythagorean theorem. I'm going to change the color on it just for emphasis. So we have, this is Pythagorean theorem. Okay, that's another way to consider. Now, when do you use this? When do you want to use the distance formula when you're talking about polygons? Remember, this is a section on polygons. Why would we need to use the distance formula? Well, if you have a shape and you don't know what it is, the distance formula could help us determine if the sides are congruent. Okay, so if we know the sides are congruent, for example, if we know opposite sides are congruent, then we know it's a parallelogram. Or we could determine if diagonals are congruent. Okay, if the diagonals are congruent, it narrows it down to, is it an isosceles trapezoid, is it a rectangle, is it a square? So both these pieces of information give us clues as to what kind of shape we're talking about. Check this out. I'm going to change the color here. I think that'd be cooler. And this one, I don't know how it happened there. Didn't want to change. So that Pythagorean theorem, and maybe I'll put that in parentheses. Okay, so that's the distance formula. We can determine if sides are congruent or diagonals are congruent. Let's go to the next one, midpoint formula. What is the midpoint formula? Well, the midpoint formula, m, the midpoint, is equal to, we add our x's together, our x coordinates, and we divide by 2. Essentially, you're finding the average of your coordinates. Same thing with the y. Add your y's together, divide by 2, and we're done. Okay, so just a quick refresher on that. And that's it. That's the midpoint formula. That will tell you the midpoint between those two coordinates, x1, y1, x2, y2. Why would we use the midpoint formula? What would we use, why do we need to use that to determine what? Well, we want to know if, sometimes, if the diagonals bisect. I should go lowercase here. I already started that trend. Diagonals bisect. Okay. Now, if the diagonals bisect each other, okay, and we find that there is a midpoint, we can determine if it's a parallelogram or not. That's a big clue there. So if we know it's a parallelogram, we can determine some other things about it. Or we can determine a midsegment. Is something a midsegment? Or we could find a midsegment. The midsegment is especially useful for trapezoids. Okay, so that is just something to keep in mind. Midsegment, think trapezoids. But you can use a midsegment for anything. All right, last and not least, we have slope. What is slope useful for? Well, first we need to figure out or remember what is slope. I've been using the abbreviations. So slope, I'm going to write it out because slope is generally referred to as m in the y equals m. Then I'm getting off track. Slope is equal to the difference in y's, y2 minus y1, over the difference in x's. Okay, and just a reminder, it's the same thing as rise over run. Now, something that's important with polygons, okay, something with slopes, is a parallel slope. Okay, well, how do we know a parallel slope? Parallel slopes have the same slope. Okay, same/equal slopes. A perpendicular slope, perpendicular, long word, have opposite reciprocal slopes. Okay, so that's something to keep in mind. And I'm going to change the color on this for emphasis like I did up there. Like that. Okay, style, we'll make this red. Oh yeah, that looks good. Now we're popping here. So we have parallel slopes, perpendicular slopes. Why do we need to know if sides are perpendicular or parallel? Well, this helps us with a couple things. One, we can see if opposite sides are parallel. Why would we need to know that? Well, if opposite sides are parallel, then we know it's a parallelogram. Or we can figure out if it's a trapezoid, if it only has one set of parallel sides. We could also determine if the diagonals are perpendicular. If the diagonals are perpendicular, then we know it's either a rhombus or it is a square. Okay, so that's useful information also. And we can also determine if the sides are perpendicular. If the sides are perpendicular, then that means we have 90-degree angles. And if it's 90-degree angles, then it's either a rectangle or a square. So all three of these different formulas help us determine a lot of the properties of the different types of polygons we are going to encounter in the coordinate plane. So let's go over an example, okay? One type of a polygon is a triangle. So is triangle ABC, in this example right here, scalene, isosceles, or equilateral? All right, so let's go ahead and plot these points, and then we're going to go from there. So A is 0, 1. That's here. Okay. B is 4, 4. And then C, let's label it. Sorry, I should label it. Not that it's too important. A, B. And then C is 7, 0. 4, 5, 6, 7. So that's 7, 0. Oops, that's C, right? Okay. What I'm going to do is going to connect my lines here. Make a cute little triangle. All right, nice. Okay, so there's my triangle, and I can't really tell if it's scalene, isosceles, or equilateral. So what do I do? Which one of these formulas should I use? Well, I don't really care about diagonals. Triangles don't even have diagonals. I don't need to know about a mixed segment, and I don't need to know if opposite sides are parallel or perpendicular. It's not asking for a right triangle, so I don't care about sides being perpendicular. All I care about is what are the side lengths. And if I'm looking for side lengths, the key word there is length. Anytime I'm looking for length, I need to use the distance formula. Okay? So how do I do that? Well, I can go over here and I could label the points. I could call this x1, y1, x2, y2, and then I could use the distance formula to find the distance between A and B right here. I could do that, okay? I think the easier option, when you already have it drawn on the coordinate plane, like if it was just this and I didn't draw it on the coordinate plane, it might be easy to use the distance formula. But if I already have it drawn on the coordinate plane, I greatly prefer the Pythagorean Theorem. Okay, so what I'm going to do here is I'm going to show you how to use the Pythagorean Theorem. What you can do is you can draw a little triangle here, and because you're drawing straight up and straight to the right, that is a 90-degree angle. So then we have different side lengths. We have this side right here is 3 units. Okay, how did I get that? I go 1, 2, 3 units. Okay. Now, this side over here, 1, 2, 3, 4 units. So what I'm trying to find here is I'm trying to find this missing side, and we can call it C. C is just like the hypotenuse, the longest side. Pythagorean theorem says a squared plus b squared equals c squared. Okay, so I know C is my longest side, my hypotenuse. So I'm going to put in 3 squared plus 4 squared. Those are my two other sides, 3 and 4, and that is going to be equal to c squared. Let me move this up. So I get 9 plus 16 equals c squared. That's 25 equals c squared. To undo the square, I have to take the square root of both sides, and I get c equals 5. So I know this distance here is 5. Now, if you're like, whoa, 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 I'm not a big fan of Pythagorean theorem. You're doing too much work. I want you to show me the formula that you just did. Well, first off, if you want the formula, I'll give it to you. It's a squared plus b squared equals c squared. So technically I did show you, okay. But if you want me to use the distance formula, fine. I'll show you the distance formula. The distance formula is d equals, and if you want to find it between a and b, so distance of AB is going to be equal to the square root of the difference in my x's, 4 minus 0 squared, plus the difference in my y's, 4 minus 1 squared. So I get the square root of, I get 4 squared plus 3 squared. So there's a square root of 16 plus 9, the square root of 25, and equals 5. So some of you be like, that's way easier. I like that. Some of you be like, oh, Pythagorean Theorem, I can do that in my head. I like that. That's way easier. Whatever you like is fine. Okay, I like giving options, and then you choose the best option for you. So we're just going to move on. I'm going to change the sides here. We're going to do BC. So BC, I'm going to use Pythagorean Theorem again. Okay, that's just what I like to do. I see that it's 3 units to the side. 1, 2, 3, 4 units down. So it's a 3, 4. And for those that know automatic triangles, we know it's 5, but just in case you don't, 3 squared plus 4 squared, this is 9 degrees, so it's another Pythagorean theorem. You only can use it with right triangles. 3 squared plus 4 squared equals c squared, so I get 9 plus 16 equals, and then c squared. 25 equals c squared. Square root of 25, square root of both sides, sorry. Square root of 25 equals 5, so 5 equals c. So we get 5 again. So we know it's at least isosceles. It might be equilateral, but it's not scalene. Scalene means all the sides have different lengths. So now we're on to our last one. Okay, so we're on to our last segment, and I'll use the what do you call it, distance formula for this one. Okay, so we're doing 7, 0, and 0, 1. So we're doing this side here. And I'll show you the distance formula. Even though I'm not a huge fan of the distance formula, I'm going to show you. So what we do here is the distance of AC is going to be equal to the square root of the difference between the x's. So that's 7. I'm going to go the c minus a. So I'm going to go 7 minus 0 squared. And I have to go in the same direction again, plus the difference in my y's, 0 minus 1. So I could call this x2, y2, just so you know, x1, y1 squared. So I get the square root of, that's 49, plus negative 1 squared, that's going to be 1. So the square root of 50, we already know it's not the same. Square root of 50 is not the same as 5 and 5, so I have two sides that are congruent, so it makes it isosceles. And we're done. Okay, moving on to the last one. I'm going to try to do this quickly here. Is it a rhombus? There's a couple different ways. One way we can find out if it's a rhombus if all the sides are congruent. Okay, so we could go through and we could find, okay, are all these sides the same length? We could create triangles, okay, Pythagorean theorem, all that jazz, distance formula, whatever you want. That's one method because that's one of the characteristics of a rhombus. The other characteristic of a rhombus is that the diagonals are perpendicular. So what we can do here is we can find the slope of the diagonals. Okay, here's one diagonal. We can find that slope, and then we can find this slope, and we can see if they are in fact 90 degrees or not. So is this 90 degrees, question mark? If it is 90 degrees, then it is going to be a rhombus. If it's not, then it's not going to be a rhombus. So is this 90 degrees, question mark? That is the question. So let's go ahead and start with the slope of AC. So the slope of AC is going to be equal to y2 minus y1 over x2 minus x1. My y2 here, well, let's call this y2, this one x2, this one x1, y1. My y2 is 5 minus 1, so that's going to be 5 minus 1. My x2 is 4, 4 minus a negative 2. Be careful with the negatives. So we get 4 over 6, reduce it, 2 over 3. Okay, always reduce because then it becomes easier to compare them at the end. All right, let's just do some thinking here. If it's perpendicular, then we're going to have an opposite reciprocal slope. So an opposite reciprocal slope should be opposite, so it goes from positive to negative, and then reciprocal. 2 over 3 becomes 3 over 2. That's what it should be if it's perpendicular. Okay, what is it actually? We'll find out. We need to find the slope of this green diagonal. Okay, so we're going to find the slope of BD. Slope of BD. Okay, so let's start on this guy. Same thing, y2 minus y1 over x2 minus x1. I'm going to label my points x1, y1, x2, y2. So my y2 is 1, my y1 is 4 over 2 minus 0. So I get 1 minus 4 is negative 3, and then I get 2 minus 0 is 2. So I get negative 3 over 2. Okay, so guess what? This was, I'm just going to double check. So we get 1 minus 4 is negative 3. 2 minus 0 is 2. So I did get negative 3 over 2. So guess what? This is going to be a rhombus because my diagonals are perpendicular. We have perpendicular slopes to one another. So that is a good sign that it is a rhombus. Okay. These are perpendicular. So it is check. Diagonals are perpendicular. Okay. Now the other thing I need to check, that's one check. I really should double check just to make sure all my sides are congruent. So I'm going to check to see if my sides are congruent. And there's a cool trick I use. I'll show you so you don't have to do the distance formula each time. You can check by counting the squares. So we can go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. It should have the same relationship with each one of these. So I have 4 and 8. Okay, so 4 and 8 here gives me, if I were to do the Pythagorean Theorem or distance formula, that would be the square root 8, 4. Sorry, we get 64 plus 16. I'm doing this quickly. Sorry, I'm running out of time. And that would be 70. That'd be the square root of 70 would be equal to, no, that's 80, isn't it? Yep. Okay. This one would be 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if that's 2 and 8, that means that these are not perpendicular. Okay, because notice here, this is a 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. We have a problem here. So those are not, sides are not all going to be congruent. We have two sets of sides that are congruent and ones that are not. So we have a problem. I think I may have done, I see what I did wrong. I think with slope of AC, I think I subtracted by the wrong thing. So I did 5 minus, it should have been 5 minus 0. I don't know where I got the 1 from. Maybe you guys saw this earlier, but I noticed something was off. So we have 5 minus 0. Sorry, I'm checking my answer here. Let me show this in more emphasis, different color. So I had 5 minus 0, and that should have got me 5 over 6. I don't know how this happened. So I got 5 over, and then 4 minus a negative 2. That is correct. So I got 5 over 6, negative 3 over 2. Guess what? These are not perpendicular slopes. If it was perpendicular, what do we need to check the sides? The sides would definitely be congruent because the diagonals are congruent. But see, these are not perpendicular. So this is not a rhombus. So that's no. Sorry about that. That would have saved us a lot of time. But now you can see we double-checked our answer, seeing if sides were congruent, and they weren't. So now we know the diagonals are not congruent as they were the first time. So we clarified that. I'm glad you guys saw my mistake so you guys can learn from it in the future. Thank you for watching this video. I hope you enjoyed it. Be sure to tune in next time on Wesley Explains Best.